All right, Unit 6. So Unit 6 was all about algebraic expressions, right? So algebra. That was that inverse operation stuff, solving for x type of thing. So I'm just going to go through like each type that we did, right? 6.1 was just kind of your basic inverse operations, and then 6.2 was throwing like terms into the mix there. And then 6.3 was inequality. So I was going to give you guys a few examples of each to get you thinking in these terms again. So all right, inverse operations. So what do we mean by that? So I'm just going to give you an algebraic expression here to kind of point it out. So let's say you had something like this. Let's say we had 2x plus 1 is equal to 5. All right, so now if I'm going to solve for x, then what I've always said is you've got it, you think about it like an onion, right? If you want to get to the center of an onion, you got to work your way in. You got to go through like the outside and work your way in. So what that means is I got to get x on its own, but to do that, I got to get rid of this 1 and I got to get rid of this 2. And the way that we get rid of them is by moving them over to the other side, right? So I want to move the 1 over there and I'd like to move the 2 over there so that I just got x sitting by itself in the end here. And the way that we move them over there is by doing the inverse operation. So what an inverse operation is the inverse of adding is subtracting, and the inverse operation of multiplying is dividing. Okay, so those are like the pairs that go together, right? So let's do this one and just talk through it. So if I want x on its own, then I first have to decide whether or not the 2 or the 1 is the one to go first. And it's going to be the 1, right? It's really the opposite of BEDMAS, right? Because we're like undoing all those things in BEDMAS or order of operations. But another way to think about it is you want to start on the outside and work your way in. So this 1 is just kind of hanging out there. It's like easy to get at. So in order to get rid of that, I'm going to have to subtract 1 from both sides. So minus 1, minus 1. And remember why that worked was because when you subtracted 1 at this point, 1 minus 1 is 0. So it actually cancels. It goes away. That's how we got it to. That's how we got rid of it on the left-hand side there. And then on this side, we've got minus 1. So then I'll actually do that, right? And remember in math, we work our way down. I'm not going to write the next step over here. I'm going to write the next step below it. So then we're going to have left here, we're going to have 2x is equal to, and then I'm really going to go 5 minus 1. So that's 4. Okay. Now I've got one more thing to get rid of. I got to get rid of that 2. And right now, if it's written beside the x, that means it's being multiplied by x. So what's the inverse operation of that? The inverse operation of multiplying is dividing. So we need to divide by 2. And then divide by 2 on both sides, right? Whatever you do to one side, you have to do the other. Okay, so now remember what this did too. 2 divided by 2 is 1, right? And that essentially got rid of it because 1 times x is really just x, right? So we wanted that to be a 1. We didn't want that to be a 0 like it was when we were subtracting. So, okay, so then that's 1x or just x is equal to 2. And there you go. Algebra in a nutshell. Okay, so that's your inverse operations. So I'll give you just a few more examples here. So let's say we had 3b over 2 is equal to 7. And we were going to solve for b there, right? Okay, so it could be written like this. And then I also want you to recognize it could have also been written like this, where it would have been 3 over 2 times b is equal to 7. Those would be exactly the same thing. You can handle them exactly the same way, right? They're just kind of written a little different, okay? So anyway, I've got to get rid of the 2 and I got to get rid of the 3. Now, in this case, multiplying and dividing don't actually have, like it doesn't actually matter which one I do first. I can get rid of either one of them first. I typically like to get rid of the denominator when I can. I just don't like things in the denominator if they don't need to be. So I'm going to get rid of that one first. So I'm going to multiply both sides of the equation by 2. And the reason why I multiplied is because I was dividing, right? I want to do the opposite. I want to do the inverse operation. So looking at what that did, right? I'd multiply both sides by 2. That's 2 over 2. Again, they cancel, right? So now that 2 is just gone. It turned into a 1, but ones you can think about as not even really being there anymore, right? So, okay, so those cancel. What I have left is 3b is equal to 7 times 2 is 14. Okay, one more thing to get rid of. I have to get rid of this 3. So I'm going to divide both sides by 3. Okay, and then that's really it, because what I have left is b is equal to 14 over 3. Now you could put that in your calculator and go 14 divided by 3, but typically we just leave it at this point. Just leave it like that fraction. You would reduce the fraction if you could, though. All right, let's do another one. So let's do, what's a good one here? One that might mess you guys up. Let's do one like this. So let's say we've got 34 is equal to negative 2x plus 2. All right, so now a couple things have changed here. Now I've got the variable, the x, is on the right-hand side, but that doesn't matter, right? I just need x on its own. So I'm like, yeah, it doesn't really matter what side it's on at all. Just needs to be on its own. So, all right, we'll do the same thing here now. So what we're gonna do, we're gonna get rid of, well, the 2. I'm gonna get rid of that 2 on this side first. And the way I'm gonna get rid of that is by subtracting 2 from both sides. So minus 2, and then subtract 2 from this side, so minus 2. Okay, so now we've got 34 minus 2 is 32, is equal to negative 2x. All right, so what do we do with this? This one always messes kids up, because they're like, okay, they see this negative 2 and they're like, oh, I know what to do. We need to add 2. But that's not right. And the reason why it's not right is because you got to think about what you're doing to the variable. We're multiplying, right? Here, this is really negative 2 times x. So what I have to do here is I need to divide by negative 2 on both sides. So divide by negative 2 on that side as well. So then let's think about what happened there. We had negative 2 divided by negative 2. Perfect. That's positive 1. So that's gone. Like, I like that that's a positive 1, because that's like positive 1 times x, which is just x, right? So that's good. That's an x now. And now on this side, I've got 32 divided by negative 2. Positive divided by a negative gives you a negative. And then 32 divided by 2 is 16. So we get negative 16 for an answer there. All right. Let's move on to the next stage here. So 6.2. So just throwing like terms into some of the questions now. So let's say we got this. Let's say we've got 3a plus 4 minus 2a is equal to 8. All right, so remember what like terms are, right? Like terms are terms that, like the name says, are alike, but what that means is that they've got the same variable, right? So I can see that this 3a and this negative 2a, those are my like terms. Okay, so why is that important? Is because if you have like terms, then all you have to do is just add the coefficients out front. So what I mean by that, let's say if I had it written like separately over here, if I had 3a minus 2a, that's like saying, okay, I have 3 apples and I subtract 2 apples. How many apples do I have left? Well, I would have 1 apple, right? So you can treat it like that, right? So even though these things are here too, right? They're not written in the right order. I've got 3a and I've got negative 2a. I can just combine those right now and call that 1a. All right, so if I do that, I've got a, I've still got the plus 4, and that's equal to 8. Okay, so now I just need to get rid of that 4. So I'm going to subtract 4, so we get a is equal to 8 minus 4 is 4. And there you go. All right, let's make it harder. So let's say now we do this. Let's say we have 3 times 2x plus 3 is equal to 2 times, let's say 4x minus 5. All right, so I've thrown brackets into this one now too. So before we get going here, let's look at what my problems are, right? Like I need x on its own, but first off, like which x, right? I've got an x on both sides of the equation here. So I need them, really what I want to do is I want to get my x's on the same side of the equation and all my numbers on the other. But my other issue I have going on here is they're kind of like locked up in these brackets right now. I need to free them from the brackets. So how do we free them from the brackets? Well, we distribute, right? So we've got to go 3 times 2x and then 3 times 3. So I've called that rainbow in the past. And I've got to do the same for this one. I'm just going to distribute that. So this would be 3 times 2x. So that's really just 3 times 2, and then the x is still there. So we'll have, so that'll just be 6x. And then 3 times 3 is positive 9, so plus 9. And then that's equal to 2 times 4 is 8, and then don't forget the variable x. And then 2 times, and then think of this as 2 times negative 5. So that's negative 10. All right, so I got rid of the brackets, so now we're pretty good. But now my next step is I got to get my like terms on the same side. I got to get those x's on the same side, and just my numbers on the other, right? 2 ways we could do this. I could bring the 8 over there, and then so what I'd be doing is I'd be subtracting 8x. So I'm kind of looking ahead though, and if I did that, I'm going to have 6x minus 8x. I'm going to have negative 2x. Which is fine. I could do it that way, but I kind of like to keep things positive if I can. So what I'm going to do to keep it positive is I'm going to move this 6x over there instead. And the way that we do it, right, you can do it really quick and easy. I know that when this comes over here, you can think about this as being positive over here. It would just be negative 6x when I bring it over. Really what's happening is I'm going to subtract 6x to make that 0, right? Those would cancel. And then I'd have, minus 6x bringing it over there, right? Just doing it to both sides, right? But quick and easy, you can just move it over there, just change the sign on it, right? So, okay, so what we have left when we do that, we've still got 9 on this side. And over here now, we've got 8x. And here, you could just write this the same way I did, minus 10x minus 6x. That was probably an awkward way to do that. Yeah, I'll keep it that way, but the 6x could have been in front of the negative 10 too. So either way. All right, so now I don't like this negative 10 being on this side. I'd like it over there. Okay, so again, nice and easy. It's negative over here. What would it be over there? It'd be positive, right? So that's gonna be plus 10, but really this is what we're doing. We're going plus 10, so those cancel, and then plus 10. All right, so cleaning this up, we've got 9 plus 10 is 19. And then we've got 8x minus 6x is 2x. Hopefully you kind of saw what I did there. I kind of made that a little bit more confusing than it had to be with the way I wrote it, but either way. Okay, anyway, so now we just need to get rid of that 2. So I'm going to go divide by 2, divide by 2. And that's it. We would just leave it that way. 19 over 2 would be your answer there. Okay. So let's see. Should we do a really tough one? Let's do a really tough one. Let's do one like this. Let's say we had 3 over 2 times x plus 4. I'm gonna say 2x plus 4 is equal to 7. All right, so now with algebra, there's lots of ways to do these questions, right? We could do this like all kinds of ways. So one that I could do, right? I've got this fraction up front. I could distribute this, right? You could distribute that in. That'd be 3 over 2 times 2x, right? I'm going to end up with some fractions going on there. Actually, I won't in this case. It'll work out nice, but you might end up having that. So you could do that. That'd be fine. Just multiply them in. But I think the easier way that I might do this one is, well, okay, looking at this, I've got x trapped on the inside, right? And then this 3 over 2 was on the outside. So I can get rid of this guy first, right? So if I just get rid of everything on this side first, then I could start working on the inside of my brackets there. Okay, so what I'm going to do is I'm just going to get rid of that 2 that I don't really like being in the bottom or in the denominator. So I can get rid of that quite easy. All I got to do is this. I just got to multiply both sides by 2. All right, so perfect. So now what that did, I've got 2 over 2, those cancel. And now I have an expression without a fraction, right? Like I know people don't like fractions if they don't have to use them. So plus 4 is equal to 14. All right, nice. So now I'm just going to get rid of that 3. So I'm going to divide both sides by 3. And that's because I was multiplying there, right? So the inverse operation is dividing. So now we've got 2x plus 4 is equal to 14 over 3. Oh, gross. This one's going to be a little bit, this one won't be as nice, but we can do it. So now what we're going to do. So now I got to get rid of that 4 and I got to get rid of that 2. Remember, this is the first one to go. It's like farther away from the x. So I'm going to subtract 4 from both sides. So minus 4 and minus 4. All right, so here's our issue. Now we've got 2x is equal to, I've got to add this fraction. Okay, well, that's not too bad. You guys know how to do this, right? What do you need when you're adding or subtracting fractions? You need a common denominator, right? So what I'm going to do is I'm going to rewrite this. Instead of being just 4, because this was like 4 over 1, right? I'm going to write this instead as, well, I'm going to multiply the bottom and the top by 3 because I need the denominator to be the same. So in the end, this will be 3, right? So let's rewrite that one more time. That would be 14 over 3 minus, and then 4 times 3 is 12. So 12 over 3. All right, so now I can combine those. They've got the same denominator. So we've got 2x is equal to 14 minus 12 is 2 over 3. All right, we're almost there. Let's get rid of this 2. So that 2 is being multiplied, so I'm going to divide by 2. And remember what dividing by 2 means. That really just means that I can put it down here, right? That is dividing by 2. When it's in the denominator, I'm dividing by 2. So it is like down there being multiplied by the 3. Okay? Now you could call that 2 over 6 and then simplify that to 1 over 3. That'd be fine. But the other kind of nice and simple thing we can do here, I've got a 2 on the top, I got a 2 on the bottom. Let's cancel those. I've got x is equal to, and when I cancel the top, there's still a 1 there, right? It's not going to be 0, it's going to be 1. So you'd have 1 over, and there's still a 3 in the bottom. If you didn't like that, that's fine. You could have called this 2 over 6 and then simplified that down to 1 over 3. They'd do the same thing. But like I said, as we get more into high school math, this idea of canceling these is going to become more and more important. So I just want you to start to think about doing it that way. All right. Okay, so that was that one. So now let's quickly do algebraic inequalities. So inequalities, what that is, that's like your greater than or less than, your, those type of symbols. So let's review for a second, like the way it works again with the alligator and which one it eats. So the way you would say it is 3 is greater than 2. So the way it works is that it always opens up to the bigger number. So if it was an alligator, it wants to eat the bigger one, right? Those are my alligator teeth. Okay. Now, if I had something like, if I wanted to say x is greater than 4, then it would be like this. It'd be either like this. It'd be x is greater than 4, or it would also be true to say this. You could say x is greater than 4. It doesn't actually matter which way you write it, as long as it's opened up to the x, because the x is the bigger one. Okay. Now, if I wanted to say x is greater than or equal to 4, then it would be like this. It'd be x is greater than, and then a little line underneath to say equal to 4. So that means it can be everything bigger than 4, or it could be 4 itself. Okay. So that's the way those work. Now, let's do you can also do algebra with these too, though. So I can do stuff like this. I'll say 2x minus 1 is greater than 4. I really like 4s right now for some reason. Okay. So what does that mean? Well, I can't really see quite clearly what values of x would make this true. So what I always want to do is I want to do a little bit of algebra beforehand to see what just x itself has to be. So really that means do some algebra with this and just treat this, like your inequality symbol, like it's an equal symbol, right? We're just going to do everything we just did above. So this isn't hard. We can say, so this is like minus 1. I'm going to say, okay, plus 1, right? Doing the inverse operation. So plus 1 and plus 1. So we get 2x has to be greater than 5. Okay, last step, I'm going to divide by 2. Divide by 2. So we get x has to be greater than 5 over 2. Okay, what is that number? We should probably write that, if like we're gonna put this on a number line in a second. I'm gonna write this a little bit different. I'm gonna say that this is 2.5, right? Just writing that as a mixed fraction. So how many times does 2 go into 5? It goes in 2 times, and then you have another half there, right? So anyway, I wrote it that way. You could also put in your calculator. If you did that, you'd end up, if you go 5 divided by 2, you'd get 2.5, right? But either way, now let's actually sketch this out on a number line. Like how does this actually look? Well, what this would mean is this. So there's our number line. And I'm saying X is greater than 2.5. So if this was 0, and that's 1, and that's 2, 3, and 4, then the way we'd sketch this is so 2.5 is right in the middle. So we would have an open circle and then a line. I'll make the line red. I'll make everything right here. So an open circle and then the line going to the right. Now, the reason why it's an open circle is because it's just greater than, right? So what that means is it doesn't include the point 2.5 or 2.5, right? It doesn't include that point. If this was greater than or equal to, like right from the beginning, everything would be the same, but this would just be a solid dot. It just means you also include that point, okay? All right, so hopefully that makes sense. Yeah, so that's the gist of it. I won't go too much more into that. Let's just quickly go over some like word problems here to see like, you know, how we would write these things out. So this one says the maximum seating capacity in a building is 436 people. So how would you write that as an inequality? So first off, let's just figure out what we're looking at. So it says the maximum seating capacity. So that means if the seating capacity is X, right? Like how many people it can fit, then you would have to say X has to be, so if it's the maximum, right? That means I've got to be less than this number, right? That wouldn't make any sense for me to say X has to be greater than 436. That would mean that like you have to have more than 436 people in the building. So it's the other way around, right? X has to be less than, but in this case, it says maximum seating capacity of a building is 436. So what that means is that it could also be exactly 436. So we'll say X has to be less than or equal to 436. Okay, so there you go. There it is written as an inequality. All right, next one. So Mr. Brown is saving money to buy a new calculator. After 1 weekend of work, he earns $40 to add to his savings. The calculator is $115.96. What inequality may be used to represent the minimum amount he must earn to pay for the calculator? So in this case, the amount that he must earn is what we're going to call X, right? So this is what he's got to earn. And he's made $40. He already has that, right? That's like a constant here. So I can say X plus 40, right? That would be like the total amount of money that I need to have, right? Well, that has to be greater than 115.96. And then just looking at this a little bit closer, it actually has to be greater than or equal to the price of the calculator, right? Because I could have exactly the price of the calculator. So as long as it's greater than or equal to, then I would have enough money. So there you go. That's how you would write that out as an inequality. Okay, so we'll end it there.